Okay, so we're going to be looking at loans and geometric series. Now, this is what most of the HSC questions will be on. It's a very precise method. Just really practice this method over and over again. I'm just going to show you my really rough working out for this question. It looks pretty nasty, but it really is a process that once you do it over and over again, you can do it. It's not too bad. You just need to make sure you practice it a lot. So in this example, find the amount of the monthly repayments on a home loan of $960,000 at 3% per annum, compounding monthly over 30 years. How much is paid off altogether as well? So we have to find the amount of the monthly repayments and how much is paid off altogether. So our N is the number of repayments. So it's 30 years, but they're monthly, so 30 times 12. So there'll be 360 repayments. Our interest rate is 3% per annum. Now remember, we need that per month as well because it's compounding monthly. So, and we need it as a decimal. So 0.03 divided by 12, which is 0.0025. So that's the number we're going to be using in these calculations. Okay, so let's start the process. So the first thing we need to do is work out how much we owe after each month. So we do that by saying, first of all, what do we owe after the first month? So after the first month, we have the $9,600 that we borrowed, and we have a month's worth of interest on that, and that's compound interest. So that's 1 plus the rate. Okay, so we've earned a month's worth of interest has gone on to our loan. Our loan has increased. And then we take off a repayment. Now, we don't know what the repayments are. At the moment, we tend to use the letter M for repayment, M for monthly repayment, I guess. But even if it's not monthly, we still tend to use the letter M. Now, this will generate our recursive line. It's our recursive process. So that's our first one. Now we don't need to work out what that equals. You do not put this in your calculator at this process. It's really important what order you do these things in, and I'm actually going to add a few little tips to this page before I take my still shot. So we follow this to work out our recursive thing. So A2 after the second month, it's not 96000. I'm not sure if I said the right number of zeros. It's not 960,000 anymore. Okay, that number has now changed. Everything else is exactly the same. Instead of 960,000, it's A1. Everything else is the same. So you can always work out this line from that line. And that's going to mean that as well that A3 will be A2 times that minus M. So that continues each time. And that's why it's recursive. Okay, there's repetition, it repeats, yeah. So now we need to work out what this is. Now this is one of the biggest tips I've got here. And I'm just going to leave a line so I can actually write as well what I'm going to say. We need to write this number for A1. Now my tip is to write brackets first the size of A1. Okay, that's our A1. Then write the times 1.0025 and the minus M. Write all that first, then fill in what A1 is. The reason for that is I've seen a lot of students in the past get to the end of their A1, they write this minus M, and they kind of think it's that minus M, and they stop, and they get confused, or they'll write that, but they'll forget this minus M. But if you write that all out first with the big brackets, you're much less likely to forget. Okay, and then we just need to expand these brackets. So it's this whole thing here multiplied by that, and the M as well multiplied by that. I just drew the rainbow things at the bottom because I'm leaving that space for that tip. So let's see what that gives us. So it's the 960,000 times that, so it's that squared. Okay, so 1.0025 squared. minus m times this, 1.0025 minus m. Okay, and now we do the same thing again, one more month. Okay, so we do our A3. So our A3, we're writing this line, but with 3 and 2 instead of 2 and 1. Okay, so A2, 1.0025 minus m. Okay, we must write that line each time. If you don't write that line, you're much more likely to make mistakes. Write brackets first, the size of this whole A2. Okay, that's the A2 times this. All right, minus the m, and then fill in your A2 after. So 960,000, 1.0025 squared minus m, 1.0025 minus m. Okay, and then we just need to expand this bracket times this thing. Okay, so that times that thing times that, and that thing times that. So 3 multiplications. So this first one is 960,000, 1.0025. That was squared times another one, so that's now cubed. Minus this one times that, so m 1.0025 squared minus m times that. I really suggest you do draw these rainbows on so you don't forget to do all 3 of them. It's really easy just to accidentally do 2 of them instead of all 3 of them. Okay, now this is where we look at the pattern that we've got and we write one for AN. Okay, so AN following this line here, it's exactly the same. It's A of n minus 1, all right, 3, 2, n minus 1 times that, minus m. Okay, now writing that line is not quite as important. What we need to do is really have a look at our pattern. Okay, so actually you don't really, I might just rub out that line, you really don't need that line for the AN one. It's really not that important. Okay, make sure you do it on 2 and 3, but don't worry about it for AN. Now let's look at our pattern. So what we can see here, first we just had that, then we had that, and then we had this. Now let's look at how that's changing on each line. So we always had a 960,000 times this. This is our compound interest going on to that 960,000. So by n months, okay, our power is going to change. When it was 3, it was 3. When it was 2, it was 2. When it was 1, it was 1. So our power there will be n. Minus m times. Now, we've got to, this is kind of like 10025 to the power of 0. You don't have to write that, okay? I might actually rub it out before I take the still shot, but technically that's what it is. We've got a power of 0, a power of 1, a power of 2. So those powers keep increasing, and the highest power is 1 less than this number. So here, it'll be to the power of n minus 1. And then there's going to be a bunch more of those terms, dot, 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 right? A bunch more of those. And these will be the last 3. Here we had minus m. Here we had minus m times that minus m. Now we've got 3 of them. So this one we're going to, here there were 3 of them for 3. Here we're going to have n of them. And the last 3 would be those 3 again. See how that one was repeated here and then there was one more? Okay, so that's going to be minus m 1.0025 squared minus m 1.0025 minus m. Okay, remember that bit gets, that's just not there. Okay. Okay, so what you want to do now is factorize out the m's so that this whole thing becomes a bracket. Okay, actually I'll leave a line so I can write that note there. So 960,000 1.0025 to the power of n minus m bracket. Okay, so minus m is coming out the front. So we've got, I'm not going to put the brackets anymore around that stuff, I don't need to. Now it's going to become a plus because I've put the minus out the front. Dot, 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 plus this one, 1.0025 squared, plus 1.0025 plus 1. Okay, the m's out the front. And then the next thing is just to turn this around. So we write that one first, then that one, and so on. So 960,000 1.0025 to the power of n minus m. So 1 plus 1.0025 plus 0.0025 squared plus dot, dot, dot. And the last one is 1.0025 to the power of n minus 1. Now, hopefully at this point, you're going to recognize this as a geometric series. Okay, it is a geometric series. These will always give you a geometric series. Okay, and we've got, it's a GP, A equals 1, R is that divided by that, which is 1.0025 divided by 1. Okay, and at this point the number of terms is n. There are n terms, that's n minus 1, but don't forget this one, 0, 1, 2. Altogether there are n. Just like there were 3 here, there are n there. So now we can use our formula a r to the n minus 1 over r minus 1. Okay, we can use that for that bracket. So that equals 960,000 1.0025 to the n minus m. Now a is just 1. I am going to write it in. You don't have to write it in. So a bracket, our r, which is this, 1.0025 to the power of n. Oops, sorry, I wasn't supposed to close the bracket yet because I haven't done the minus 1 yet. To the power of n minus 1, all over r minus 1, so 1.0025 minus 1. And that's our formula for an. Now we could tidy that up a little bit. We can drop the 1, we can tidy that up. I'm going to do actually 2 steps in once. Now notice we actually have to do, remember, 360 months. So we do actually have an n, which is 360. Okay, so a 360 is 960,000 1.0025 to the power of 360 minus m. So at this point I'll drop that 1, 1.0025 to the power of 360 minus 1. This is all just 0.0025, okay, 1.0025 minus 1. Now, 360 is when the loan is completely paid off. So at this point, our loan plus interest minus all of our repayments with their interest, okay, this is our interest on our repayments, is going to equal 0. Okay, it is paid off, loan paid off. That's the big thing we want to work out. So all we have to do is solve this equation. Now, one little tip here that you can do if you want to is actually just to put all this in the calculator as early as you want to. I'm actually just going to do one, oh no, I'll do it now. So our 960,000 1.0025 to the power of 360 minus m times, put all that in your calculator, you get 582.736 equals 0. Becomes a much easier equation to solve. But leave that in your calculator so you can use the answer button. Now all we're going to do is add that to each side of the equation, so plus m 582.736 on each side, m 582.736. So that's going to cancel. That'll be that. I'm just going to flip it around and put the m on the left. Okay, so m times, what, I put that number in front of it, that's how we're used to seeing it. Remember, we're using our answer button on our calculator when we do this as well. 960000. If you're not going to use the answer button on your calculator for this, then write a few more decimal points. Do like 6 decimal places or something like that. Okay, so all we have to do is divide each side by 582.736. That number in our calculator, 582.736. So in your calculator, put in 960000 times 1.0025 to the power of 360 divided by last answer, and you will get that M equals $4047 rounded off to the nearest cent is 40 cents per month. That's my repayments. Okay, now a majority of these questions are exactly like that. There are some variations. One variation might be that they tell you what the repayment is and you have to find this initial number. So this will be your unknown. You can use any letter you want. You can use P, X, whatever you want. Just use any number for that. Okay, and that'd be the number you'd be solving for. But you'd already know all of this. They're unlikely to ask you N, but there might be some differences as to compounding periods and things like that, and interest-free periods. I'm going to do an example. There could be an interest-free period where they don't charge any interest for a little while, where you make some repayments and then the interest kicks in later. Or an example I'm actually going to do next where you don't make any repayments at the start. You just do repayments after a certain amount of time. But in that case, the interest is probably increasing during that time. Now, we were also asked what was the total amount repaid. Okay, so the total amount repaid is that last answer. So use the A&S button on your calculator. Or actually for this one you don't really need to, because if you're paying that per month, that figure was actually rounded up. So over 360 months, you're actually going to be paying more than what you would have needed to. If that was rounding down, you'd actually be paying less over the 360 months than you need to. But with your loan, you would agree on this number and then use that number from then on. So you don't need to use the answer button. We make 360 of those payments. Okay, and that makes a total of $1,457,063.54. Okay, to the nearest cent. I did use the answer button, so I'm not sure if that rounding would be the same. No, that should be the same, because 4 6s are 424. So now we won't ask the interest, but I thought I might put it in anyway because it's interesting to see. So the interest, of course, is that number minus what our loan was, so minus the 960000. So the total interest on this loan is 497,063.54. So almost $500,000 in interest. The interest is actually more than half of the amount that we borrowed to begin with, and that's not unusual. And obviously we don't want to pay interest if we can help it, but for people to afford more than that a month, that's an issue as well. So it's always good to get a loan paid off as quickly as you can afford to get it paid off if you can, but also it depends on other situations. So if this was an investment property, for example, then there may be tax benefits involved in any interest that you have to pay. So there may not be such a hurry to pay it off. You'd always pay off your personal property before an investment property, just because of the tax involved. So an investment property, you may be happy to let it sit longer and pay more, even though you will pay more interest in the long run, depending on where you want to put your money. So there's lots of things to consider in that situation.